Good morning, dear students. Hope you are doing well. Today I'm going to explain the last part of chapter 9, the alcohols. It is esterification reaction. The objectives that I hope you will understand well at the end of this session are: define an esterification reaction, name esters, indicate the characteristics of esterification reaction, identify factors that increase the yield of the esterification reaction, and the last objective is to recognize factors that accelerate the rate of the esterification reaction. Let's begin with the first objective. What is esterification reaction? It is the reaction in which an alcohol reacts with a carboxylic acid to give an ester, which is a fruit-odored substance, with the elimination of water. How does the reaction occur? By taking hydrogen from the functional group of alcohol and the OH from the functional group of carboxylic acid to eliminate water and to form ester. Observe the structure of this ester. It consists of two parts. The first part comes from the remained alcohol, which is RO, bonded to the second part that comes from the remained carboxylic acid at the C double bond O. Here, the structure of ester can also be drawn starting from the remained carboxylic acid bonded to the remained part of alcohol. Both structures of ester are correct, so the structure of ester can be represented in two ways. What is the functional group of ester? It is OC double bond O, or as we see here, the same C double bond O. Now, how to name an ester? To name an ester according to IUPAC system is start with the alcohol part as alkyl, then with the carboxylic acid part by changing the IC of the acid by ATE and dropping the word acid, alkalonate. So what do we get? We get alkyl alkalonate. Let us represent the equation of esterification starting with carboxylic acid. Look here at the carboxylic acid. It consists of one carbon atom, so it is called methanoic acid. Now look at the alcohol, which is the second reactant. It consists of three carbon atoms. The first carbon atom bearing the OH it means here that it is primary alcohol, and we name it 1-propanol. So how the reaction is formed and how to name the ester, let's see here again. We have the OH, is taken from the functional group of the carboxylic acid, the H from the functional group of the alcohol to eliminate water and to form the ester. Now, this ester, how to name it? Let's see here the alcohol. In order to number it, you number 1, the carbon holding the OH. Number 2 is the second carbon and the third carbon. So the alcohol is 1-propanol. The acid, carboxylic acid, has only 1 carbon atom. So you look at the ester. We have here the part of the alcohol has 3 consecutive carbon atoms, so it is called alkyl as 1-propyl, and the part of the acid consists of 1 carbon atom, so we drop the IC and we drop the word acid and we write here methanoate. So as a whole, the name of the ester is 1-propyl methanoate. Now, what do we have? What is the condensed structural formula presented in this slide? It is it an alcohol, an acid, or an ester? It is an ester because it has the ester functional group, which is OC double bond O. Now, from this structure, can you figure out which alcohol and which acid reacted to give this ester? Starting from carbon C double bond O, we can figure out the acid. This carbon is the first carbon in the acid. The consecutive carbons represent the whole chain of the carboxylic acid. In this case, we have 3 carbon atoms. Therefore, the acid is propanoic acid. Automatically, the remaining carbon will represent those of alcohol. Here they are 4 carbon, starting numbering nearest to the oxygen. So it is 1, 2, 3, 4, and it is 2-butanol. Therefore, the reaction is 2-butanol plus propanoic acid to give water and ester. How to name this ester? Let's recall here that the H is taken from the hydroxyl group and the OH is taken from the carboxyl group of the carboxylic acid to eliminate water and to form ester. Now, to name this ester, we have the alcohol starting numbering nearest to the functional group. So this is carbon number 1 and this is carbon number 2, 3, and 4. So it is 2-butanol. What about propanoic acid? It is carbon number 1 is the functional group of the carboxylic acid, and you have number 2 and number 3, so it is propanoic acid. how to name the acid here, starting with the alkyl radical, which is the part of the alcohol. Here look at the CH3. It is number 1. It stays number 1. So you number it here in the ester nearest to the functional group of the ester. So it is number 1, and then we have here number 2, which is the carbon holding the functional group of the ester, number 3 and number 4. So in this case, this part of the ester is the part of the alcohol and its name is 2-butyl. Now the second part is the part of the acid, starting with carbon number 1 is the C double bond O, and carbon number 2 and the 3. So this part is also called propanoate. So the whole ester, the name of the whole ester is 2-butyl propanoate. Now, what are the characteristics of esterification reaction? Let's recall here that it is reversible reaction or a limited reaction, it is slow reaction, and it is a thermic reaction. The equilibrium constant for esterification reaction is equal to the concentration of the ester times the concentration of water over the concentration of the alcohol times the concentration of carboxylic acid. Don't forget that the water is one of the products of esterification, so it should be included in the equilibrium constant for ester. And the reverse reaction of esterification is hydrolysis of an ester. And here I want you to pay attention that the esterification reaction is a reversible reaction. We have to write it in 2 directions. Now, how to identify the factors that increase the yield of esterification reaction? First, we want to explain mole percentage of ester or percent yield by moles of esterification. The percentage yield of ester by mole is the moles of ester formed actual or obtained experimentally over the moles of ester formed theoretically times 100. Let's take an example here, but before let's see how to determine the moles of ester formed theoretically. The following definite proportion should be considered. N of alcohol reacted over 1 is equal to N of carboxylic acid reacted over 1 equal to N of ester formed over 1 equal to N of water formed over 1, because water is one of the products. Now, if the reactants are equimolar or they are in a stoichiometric ratio, you can use any of the reactants to calculate the number of moles of the ester formed theoretically. But if the reactants are not equimolar or they are not in stoichiometric proportion, use the reactant with the least ratio. Let's take an example. Here we have 0.1 mole of ethanol mixed with 0.2 mole of ethanoic acid. As you see here that the number of moles of ethanol is not equimolar to the number of moles of ethanoic acid. the number of ester obtained upon this reaction was 0.076 mole. This number of moles is the experimental value. Now, how to calculate the mole percentage yield of the reaction? It is equal to the number of moles of the ester obtained experimentally. It is 0.076, which is given, times 100 over. What do we have to use here? The number of moles of ethanol or the number of moles of ethanoic acid to calculate the number of moles of the ester formed theoretically. Here we have to find the ratio of the two reactants. So with respect, the ratio of ethanol is 0.1 over 1. The ratio of ethanoic acid is 0.2 over 1. The ratio of ethanol is less than the ratio of ethanoic acid. So what can we use here? The number of moles of ethanol to calculate the number of moles of ester formed theoretically. So, it will be 0.1, and the percentage yield will be 76%. Now, to identify the factors that increase the yield of esterification reaction, we have here the yield of esterification depends on, first, the class of the alcohol, second, the initial quantities of reactants, third, using sulfuric acid, H2SO4 as a dehydrating agent, and fourth, the amount of ester removed from the reaction. Let's take the first factor, which is the class of alcohol. The table here shows the proportion by mole of the ester formed as a function of the class of the alcohol, and starting initially with an equimolar mixture of the alcohol and carboxylic acid. So in the table, if the alcohol is a primary alcohol, the mole percentage of the ester will be 67%. Don't forget that we start with equimolar mixture of alcohol and carboxylic acid. If the class of the alcohol is secondary alcohol, the mole percentage of the ester will be 60%. If it is tertiary alcohol, the mole percentage of the ester or the percentage yield is from 1 to 5%, which is the least percentage yield. And as you observe here, that primary alcohol if we use primary alcohol, the percentage yield will be the highest. Now the second factor that affects the yield of the esterification reaction is the initial quantities of reactants. If the number of moles of one of the reactants increases, it means here we are not having equimolar initial number of moles, they are non-equimolar reactants. What will be the amount of the product? Now, in order to answer this one, let's examine well the graph here. This graph represents the variation of the number of moles of ester as a function of time in minutes. The blue curve here represents the number of moles of ester formed initially. It means here when you use initial amount that have equal number of moles of the reactants. Now, what happens when we use excess of one of the reactants? The red curve will be observed. This red curve is above the blue curve. It means the number of moles of ester formed will be more, and the number of moles of the ester or the product increases. What does it mean? As a result, the percentage yield increases. Now, the third factor is using sulfuric acid as a dehydrating agent. Adding 5 milliliter of sulfuric acid will absorb water. So dehydrating agent means absorbing water, thereby shifting the reaction forward. According to Chatelier principle, and increasing the amount of ester formed. As a result, the percentage yield increases. Now, the fourth factor is the amount of ester removed from the reaction. So by removing the ester formed or collecting the ester, the esterification reaction will be shifted forward to re-establish equilibrium according to Chatelier principle. So as a result, the percentage yield increases. Now, the last part or the last objective is to recognize factors that accelerate the rate of the esterification reaction. Recognize this graph well. This graph shows how the temperature makes the reaction moves faster. Now here you have two curves, the red curve and the blue curve. Both of them reach to the same number of moles of the product, let's say of ester. But the red curve, the temperature is lower than the temperature of the blue curve. So in this case, the blue curve will, or using higher temperature, the rate of the reaction will be faster, and reaching the number of moles of the ester formed will be faster, but keeping in your mind that you will have the same amount of the ester formed and the percentage yield is not going to be affected. It will be the same. So, to recognize these factors that accelerate the rate of the esterification reaction, the first one is increasing the temperature of the equilibrium system. The second one, adding sulfuric acid, but here with small amounts. Third, using a reflux apparatus. Now let's take the first one. The temperature is a kinetic factor that increases the rate of the esterification reaction because this reaction is athermic. It means it neither absorb heat nor release heat. In this case, the percentage yield is not affected. Now, the second factor is adding sulfuric acid in few drops. It acts as a catalyst, which is a kinetic factor that increases the rate of the reaction without affecting the yield. And the third factor is using a reflux apparatus. As you see here, the reflux apparatus, we put the two reactants together and we use the condenser and heat. This apparatus prevents losing the components of the reaction by condensing their vapors escaping and returning them to the reactional mixture. Finally, I hope all of you found interest in this topic, which is a very important topic in the official exam. Thank you.